So, hello students, good morning everyone. Am I audible?
Good morning, sir. Yes, sir.
So, this course is network design and optimization. And so here we'll be using this particular textbook. So, optimization of modeling and so this textbook is by Pablo. So we'll try to study the maybe like the part one of this text. So now in this course, like maybe maybe every 2 weeks or 3 weeks, like we'll try to have a quiz. Or you have a quiz. So now this quiz is sort of cumulative. It means that whatever that is question that was for the first quiz will be included for the second quiz by default. So it's not incremental, right? So now and you'll be evaluated for the semester. It means that all the marks that you score in the quiz, they matter for your final grade. So you already know that the grades are related. So and classes, as I've announced, will have on Monday and Tuesday. So maybe like I have another course that's running that is of the previous semester. So once that is sort of consolidated, maybe like I'll have one more day for your for this particular course. Get one more class for this course. So yeah, so we can go into so first of all, like we look at what a communication network. So do you have any queries this side? So
No, sir.
yeah. So what are the various communication networks that we see around? What are the various communication networks that we see around?
Mobile communication.
Yes, can one say something? No. Yes.
Wired.
Anything else? Anything else? These are the only two types of communication networks that you see around. I said communication network. So see, we see telephone network. So telephone network is a communication network. Right? So you have maybe exchanges, you have switching centers, you have the links, right? So the telephone wires, and you have telephone devices. So it itself forms a communication network, right? So this way, like, what other examples can you say? I can say mobile network, right? You have base stations, you have mobile switching centers, you have the end devices, right? So you have mobile network also as a communication network. At some point, like, it may also use the maybe at some level it uses the PSTN network also, right? So then we have anything else in this way?
Satellite
If you
communication
think
like TV transfer.
internet, so now does this itself form a separate network?
So it is a collection of networks.
Yes, I didn't. It's a collection of networks. Okay. So say you remove all these other networks, can this provide connectivity for the user on its own?
No, sir.
So through some
Huh?
provider.
Yes, no. Yeah, so it can provide. So we can say that internet itself is a communication network, right? So so at maybe you leave the internet. So at the within an institute, like, you may have a LAN network, right? So this is also a communication network. I mean, say you can have a LAN network which is disconnected from the internet, maybe the public links, and still, like, it provides a communication network wherein you are able to maybe access some of the contents that are local within the internet and so on, right? So you have these different types of communication networks, right? So now, if you look at any communication network, there are two basic components. Right? So the two basic components in any communication network are, first of all, the telecommunication system, and the second one is the switching system. Right? So basically, like, a telecommunication system or link, maybe basically it consists of transmitter and maybe like one or more receivers, right? Which is connected through a medium. Right? So this medium may be a wired medium or this, when we look at communication system in general, right? So when you look at the communication system in general, it consists of two basic components. One is the telecommunication system or link, and the second is the switching system. Okay? So if you look at the telecommunication system, it consists of a transmitter and one or more receivers, and it also consists of a medium through which the electromagnetic signals are passed from the transmitter to the receiver, right? Now, now, say for instance, like, if you do not have any switching system, so we don't have any switching system. Now, in that case, like, we have only telecommunication system. So only with the telecommunication system uh, uh, can we have a communication network. Assume that like you have this telecommunication system that connects the transmitter and the receiver. Can we have a uh, communication network? So if you look at the telecommunication system in our as per our definition, what I've told is that you have two users, A and B. You have let's assume that they have a bidirectional telecommunication system wherein you have a transmitter and a receiver, and he transmit and he is able to receive, right? So you have these two links both being unidirectional, right? So now being able to now what kind of link is this? This is called as a simplex. Then you
So
have
duplex link.
duplex and duplex. So now, what's a simplex link?
Communication in one direction only.
So one directional communication of duplex.
So communication on both sides, but only one at a time.
One at a time. And here you have full duplex wherein you can communicate both the sides, both the directions at the same time. Now here, like you have this kind of two simplex links which provide you a full duplex communication, right? So logically you have a full duplex communication, but physically like you have two simplex links. One is on one direction and the other is on other direction. Right? So you have this kind of a link, right? Together, like it provides you a full duplex communication, right? Now, using only this kind of a system, if you want to replicate a communication network, then what you need to do? So it connects only two users, right? So what you need to do is A as a user, say you have B as a user, C as a user, D as a user, right? Now A should have three receivers, right? So by which he will be able to get the data from uh, B, he'll be able to get the data from C, and he will be able to get the data from B, right? So, or maybe like if he wants to, if he wants to communicate with say D, or if he wants to communicate with C or with B, then maybe like he will use these three. This is a full duplex link. This is a full duplex link. This is a full duplex link. So he will be using this channel in order to communicate with D, this particular link to communicate with C, and this link to communicate with D, right? So it will act on both the sides, right? So he will be able to transmit and he'll also be able to receive over this particular link, right? Similarly, what D should do, D should have a communication link with B, and D should have one more link with C. He also should have one link with B. So it means that in order to make a communication network, so this together makes a communication network, right? So what is the problem with this kind of a communication network? A has 3 devices, right? In order to communicate with D, he has 1 device. In order to communicate with C, he has another, and with B, he has another. So basically, he has 3 telecommunication systems, right? To communicate with every user, like he uses 3 communication systems. So it means that there is replication of link, there is replication of device, right? So at every level, right? So this is not going to be economic, right? So you need a kind of a system which is called as a switching system, right? So we need switching system which should be able to help us, right? So now what the switching system does is basically like you have a kind of system, and this basically consists of several inputs, and it consists of several outputs, and basically it tries to say, put each of these links in, it connects the input to the output, right? So this is what basically the switching system does, right? So with respect to switching system, we also define something called as a switching state, right? So switching state is going to define at any moment of time what the exact picture of the switching system is, right? So what is connected to what, right? That is what is going to be defined by the switching system. So now we may have A, and he is connected to a switching system, right? And you have B, C, D, right? And now the switching system decides like how the interconnection is going to happen, right? So who is going to be connected to whom, right? So that is defined by the switching system. Right. So now what we see is that this switching system is a kind of a reconfigurable, right? So because the state can change at any moment of time, right? So now because the switching system is reconfigurable, what it does is that it enables the output links to become a shared resource. So you have an input link, you have this output link. Now, because you will be able to switch to any of this output link becomes a shared resource because of the reconfigurability property of the switching system. So output link becomes a shared resource. Now, switching is just one kind of a way, one way in which like we are able to make make use of a shared resource. We have a shared resource, and using the switching system, we are able to utilize the shared resource in an economical fashion. Right? So now it means that in order to identify different users, you need to give them some ID, maybe some number or so on. Then like your switching system will be able to switch to a specific output. So now this switching system is further enhanced because now we are also able to multiplex the links. So multiplex the. So now, what do you mean by multiplexing? What are the different types of multiplexing ring schemes that you have studied. With respect to this kind of a system, we did not have a need to say explicitly address, right? Because I knew that if I want to talk to D, then I should use this telephone. Right? If I need to talk to C, I knew that I need to use this telephone. And if I need to talk to B, then I need to use this telephone. There is no need for addressing in the middle, right? So on the other hand, if you have a switching system, then we need to have a way in which we are able to identify. Say if in the earlier days there used to be something called as a trunk call system. So in this kind of a system, the switching was manual, right? So if you want to communicate with somebody, then you call an exchange and you say the person here that I need to make a call to so and so, right? Then he does the switching manually, and then after some time you get the link to make the call, right? So now now here with the advancement of the switching technologies, things have become first of all, like you everything has become automatic. The second thing is with respect to switching, when you use a switching technology, there is a need to address each one of them, right? Uniquely identify every user. Now we come to multiplexing. So how multiplexing helps? What are the different multiplexing schemes?
So frequency division, multiplexing,
TDM.
time waves.
Space
So
really.
these are the okay. So these are the three popular multiplexing schemes. So now you have a single link, that is the shared link. Okay. Now, how are you going to further um, reduce the cost with respect to this particular link? Okay. So now one way to do is to have channels on particular link, right? So these channels are created by say either frequency division or by time division or maybe code or maybe phase, right? So now in frequency division, so say if you have a bandwidth say of 100 kilohertz, say from 200 kilohertz to say 300 kilohertz. So if you look at 2G, like it operates at around 900 megahertz. Right? So now you have at 900 megahertz, maybe you have maybe 100 megahertz bandwidth. So you go from 900 megahertz to 1 gigahertz, right? So now up till here, you divide the entire frequency into some separate channels, right? Maybe like with some channel bandwidth, you divide the entire frequency, and you transmit the signal between the source and the destination within this particular frequency. So this way, like we are able to use a single link, right? So now link also becomes a shared resource, and this shared resource is used by multiple users by having this kind of schemes, right? So multiplexing scheme. Similarly, with respect to time division multiplexing, you have a link and A transmit for, at time t1 for a short duration, then maybe B transmits at time slot t2 for a short duration, C transmits at time duration t3 for a short duration, right? So this way, like the data is transmitted, right? So and the link is used, link is shared. So this is one another way of sharing the link. Right? In code division multiplexing, right, you have a modulation scheme on your data, and you modulate the signal using some orthogonal code. Right? So you have two orthogonal codes, C1 and C2. So A, when you sends its data, it is modulated by code C1. When B sends the data, it is modulated by, say, code C2. So now at the receiver end, and the transmission happens on the same link. Right? So after some time, when the receiver receives this data, then he uses these codes to once more find out the original data that has been transferred. Right? So you have this code division multiplexing involved. So if you together look, then there are four elements in a communication network, right? So in general, we can say that a communication network consists of four elements. Right? So the first thing is the information source and destination. Right? Then you have links that are capable of transmitting. Then the third one is the switching node that um, exists in the network. And the fourth one is the addressing and signaling system. So these four elements together form some basic part of a communication network. Right? Now, if you look at communication network, they have users use the communication network, and basically one characteristic aspect of a communication network is that the user behavior is always random in nature. Say for instance, you have a telephone network. So if always it is always fixed that say you're going to use the telephone network at one specific instance in time, and similarly, like we say, rest of the users are going to use the telephone network at different gaps in time, then you don't see that the user behavior is random, because you've been allocated a fixed time slot and you're going to use the telephone network only in that particular time slot, right? But here we have a communication network, and users can use this communication network at any time, right? So you do not know beforehand which user is going to use the communication network at any point in time, right? Now, since the user behavior is random, so it poses a problem that how are you going to provision the link, or provision the resources of the communication, of a communication network. Right? So how you're going to provision the link or the resources of a communication network. Right? So you do not know before what user behavior is. Right? So already we saw that communication network consists of all these different aspects or different uh, entities, and now the question is, how are you going to provision the resources of a communication network, right? So when you do not know the nature of the user behavior, how are you going to provision the resources of a communication network? Say for instance, like if you have if you create a server, so now what are the questions that you're going to ask before selecting a server? So the important question that you will ask is how many people are going to use this server? So possibly how many people may use this server? Maybe at a time, like how many people may connect to this particular server? Hmm? So based on that, you are going to provision the resources for the server. Maybe like you will decide on the RAM based on that, maybe the processor based on that, right? Maybe other critical things, maybe the storage based on that, right? So based on what you estimate as the possible utility or possible uh, load on the server. This load on the server is going to decide on the resources that are going to be used for creating this server. So now, similarly, like in a kind of a network, say with respect to a server, it's just going to be um, one endpoint device, or maybe like it's going to be a single entity on which you need to make the decision, right? So on the other hand, like if you have a network, then you need to decide on the link capacities at all levels and the switching capacities at all levels in order to provision, in order to provision the resources of the network. So now, if at all this decision is not required, I mean, if it was, I mean, this is basically necessitated because two users A and B do not have the complete link available to only them always. This link L is not available to only these users A and B all the time. It is available to big number of users at the same time when this link is available for both A and B, right? So now that's how like it becomes important uh, um, on how this can be done. Now, now based on this, I need to decide on what should be the capacity of this link, what should be the link capacity. So now based on this, I need to look at the design. This forms a major design aspect of communication. So now when you say design, you are going to have an objective. Maybe the objective is to reduce the cost, and you are going to have some constraints. So now within this particular scope, you can define your problem and you have to optimize the resources so that the cost is reduced and all the constraints are satisfied. Okay? So now you will be able to model the problem of design as a optimization problem. Hence you have the subject, network, design, and optimization. Any problems so far? Now, if you look at the communication network design, so how the communication network has been designed so far, we will be able to see that these in order to characterize the random user behavior. So you have user behavior, and the user behavior is random. In order to characterize um, random user behavior, what is done is that often probabilistic models have been used. Right? So probabilistic models have been used. Right? So now basically, like, you look at the statistical data. Uh, Based on the statistical information, or based on the statistical data which has been observed by the users, now the network services have been provisioned such that the service degradation is small. Right. So basically, like conditional probabilities, given that this is the network design, what is the probability that user is going to wait for 10 minutes? So this kind of characterization has been done. So given this is the link capacity, then what is the probability that um, the user may have to wait for it? So basically, like, you try to give probabilistic framework. You try to model a probabilistic framework on your network, right? So now, um, so basically, like what users do, they basically do a capacity sharing. So you have a link, right, between the source and the destination, and this link is shared by many people. And when the number of people increase, you are going to have blocked calls, and if it still increases, then you are going to have dropped calls. Are you able to get this, understand this? Right? So you have this link that is used by many people. So when many people use this link, what they are doing is they are doing a capacity sharing, right? So now there are two main kind of systems with respect to capacity sharing. So those two systems may be called as say delay system and loss. Two major systems with capacity link capacity sharing may be called as delay systems and loss. Basically, like you have circuit switched network, which is this loss system, and the other thing is packet switched network, which is a delay. So, what's the difference between circuit switching and packet switching?
So in circuit switching, there is a dedicated link, and in packets, there are smaller data which are without any dedicated link.
So, So, okay, so when you say TCP is a connection-oriented protocol or a connection-less protocol?
A connection oriented protocol.
What about UDP?
Connectionless.
Okay. So now, does TCP support packet switching, or is it a layer, is it a protocol of packet switch network or a?
Yes, sir, it supports packet switching.
Okay, so now what kind of connection are we talking about? Yeah. Hmm? Please, yeah. Yes. So when we say connection oriented, what do we mean?
So at the starting of before the transfer of data, we try to like select the path which we are going to follow and then transmit the packets to them. There's a acknowledgement before sending.
So is this path always going to be used?
So for one time communication, yes. For the next time, the part selected may be different.
So I just ask you a question in TCP, like, is there a path that is set up? Or for that matter, in any packet switch network, is there any path that is set up?
No, so the path is not fixed, but the communication is set up beforehand.
So there is no path. Right? So I mean, for that matter, like packet switch network itself is that packet switching itself is that you don't have any path. That is the beauty of packet switching system, right? So now there is no path that is set, right? So except that logical connection is set up between the source and the destination. Basically, like you can say that there is a session that is set up between the source and the destination for data transmission. Nothing more than that, right? So now, because there is a session that is set up, and there is a handshaking that is being done, which is all logical in nature, and one during truncation also. I mean, you have a protocol of disconnecting. So you call this as a connection-oriented protocol, right? So and there is a way in which, like, if packets are dropped, you get to know, right? So you can ensure that the packets arrive in order. They are put together, sequenced at the destination, and so on. So you call this as a connection-oriented protocol. Right? On the other hand, like many of the mechanisms to check the data packets for the sequencing or initiation, all of that is absent in UDP, so you call this call it as a connectionless protocol. So now here, if you look at the delay systems, now you basically talk about the packet switch or packet switching networks, right? So now here in these kind of networks, what is very important is that the link capacities, they are provisioned in such a manner that the average flow of packets that traverse the links do not exceed the link capacity, right? So that's how it works, right? So it tries to ensure that the average number of packets that is traversing through this network is less than the link capacity, right? So now what happens is that you're going to have so now all the links everywhere, everybody will be checking that the total number of packets is less than the link capacity, or maybe like you have a margin here, and it will be less than the margin of data that is transmitted by that particular link, right? So now, what is the total? What is that called? You call it. The time for transmission and acknowledgement, what do you call that as? Or
RTT.
yes, round trip time. So now, how do you measure the round trip time? So round trip time is going to be equal to, or like you give
Propagation
the
delay
round trip time. Okay, so propagation delay.
plus transmission delay.
Okay,
And so into two, like it will go both direction. The
okay.
acknowledgement time.
So now, what constitutes the transmission delay?
So the link speed and I mean the time taken by the channel to transmit from A to B.
Okay, so what is propagation delay?
The time taken to put the data on the channel.
Okay,
So yeah, other way
time,
around.
time taken to put the data onto the channel, that you call as the propagation delay. Then what is the transmission delay?
The propagation delay is the time taken for signal to reach its destination.
The transmission delay is time taken to put the packet.
So propagation delay is the time that is taken to put one bit of the packet from one end of the one end to the other end. That is called as propagation delay. For
Yes,
one
sir.
bit to travel from one end to the other end is called as propagation delay. Right? Transmission delay is the time that is taken in order to put the data, all the bits onto the wire in the first place. So it means that the time that is taken for the data to be put onto the wire itself is called as the transmission delay. Right? Now, in addition to this, you also have another delay that is called as the queuing delay. Right? So because you are not just talking about a single link A to B, right? Now, if you have a single link, then the time that is taken in order to transmit the data from A to B will be transmission delay plus propagation delay. But what you have is you have several intermediate nodes. What are these nodes going to be? These nodes are going to be your switching devices. What is going to be there on the switching devices? I already told you that switching devices always work in a fashion that the link capacity is going to be their benchmark, right? So they are always going to transmit only the data that is less than the link capacity. Anything beyond, if there is a huge inflow of data that comes into this link, what they will be doing? They will be buffering.
Buffering.
So now what is this buffer called as? This buffer is called as a queue, right?
Queuing
So
buffer.
now, yeah, so now if you're buffering, then you're going to, this data is going to wait in the buffer, right? So now maybe you transmit from A to B, and at every node in the intermediate, if the data has to wait, then it's going to take a long time, right? So that's why you call this kind of a system as a delay system, right? So why it is called as a delay system? Because in a delay, in a system which is a packet switched network, you are going to have the data that may have to go through all these intermediate devices, and it may have to wait in the queues of all these intermediate devices, right? So when you do the QoS of this kind of systems, what you will be doing is, how can I reduce the delay? That becomes the important parameter. Okay? So when you are trying to provision the system, when you are trying to design such a kind of a system, then this becomes an important parameter. How to reduce the delay in these kind of networks, in basically the uh, uh, packet switch networks, right? Then the other important factor is what happens if the delay becomes very high. If I mean, say like this link is dependent on these two links, right? There is a huge inflow of packets in this particular link, right? So you have the data that may have to pass through the two links. Now there is a huge inflow of data, and the data is stored in the buffer, and still there is more data that is coming. So the buffer has become full. Now what becomes imperative?
Packet drops.
There are going to be packet drops, right? So now here we can say, how can I reduce the delay, and how can I reduce the packet loss? So what is the probability that there can be a packet loss in this system, right? So these two become the performance metrics of interest, right? On the other hand, if you have a circuit switched network, then what is the performance metric? What is the performance metric in a circuit switched network?
So optimization of throughput of the channel.
In a circuit switch network, what happens is, say you have dedicated link, right? So you have a dedicated link that exists between the source and the destination, right? So let's assume this is a shared link, right? Now this link is either here or here, right? Now what happens is, A and B are now communicating, right? Now if C wants to use this particular link, and if A and B are already communicating, there is no way to use this link. Only thing that will happen is that C is going to be blocked for the entire duration when A and B are communicating. Are you following this?
Yes, sir.
right?
Yes, sir.
So now C is going to be blocked for the entire duration when A and B are communicating, right? So this is the important factor here. So what is the blocking probability, right? Okay, so now when the mobile networks are basically, even the current mobile networks are basically in one way, I mean not in the truest way I'm saying circuit switch network. They are maybe instead of saying circuit switch network, I can say that the current mobile network is a loss system, right? So current mobile network is a loss system. So what do you mean when we say that current mobile network is a loss system? Because our communication, say if you ring a number and you make a call, then you are basically allocated a channel. You are basically allocated two channels, one for onward, one for reverse, right? So in the forward direction and the reverse direction, you are allocated two channels. I already told you, right? So the channel can be either time multiplexed or it can be frequency multiplexed or however, right? You are allocated two channels. Right? Now, as long as say now only 100 channels are available, let us assume, right? So if there are 100 channels available at one particular, so these channels are between the mobile devices and the base station, right? So this is the base station, right? So now this base station, let's assume it consists of, it has a capacity of maximum 100 channels, right? Now let's assume that 50 users are using, right, these 100 channels. Now if the 51st user wants to connect to this base station, because if he wants to communicate with anybody, he has to connect to this base station. And if the 51st user wants to connect to this base station, he will not be able to use, he will not be able to connect to this base station as long as this 50 users are using these 100 channels. Are you able to follow that? Then
Yes, sir.
the performance metric becomes, what is the blocking probability? What is the probability that somebody who wants to make a new connection request is going to have his request blocked? That is what is the blocking probability. That becomes the performance, right? This is the performance metric in a loss system. Right? So a delay system is maybe similar to a packet switch network, where what is important? One is the delay and the other is the loss. Right? The loss system is another kind of a system which is similar to a circuit switch network, where what is important is the blocking probability, right? So that is the performance metric with respect to a loss system. So I think with that, yeah, please. Yeah, yeah, I am leaving you. Thank you. Huh?
Thank you, sir.